In this video, I'm going to show you guys something pretty cool on Desmos that will help you to create your velocity function and your acceleration function for the PSMT without having to actually go and differentiate each function. Now, obviously part of your PSMT, the mathematical component, is to use differentiation to solve this problem. So although this is going to be a cool thing to see, it is still important for you to derive all of your functions algebraically, but this, I guess, just saves you having to type them into Desmos. So I've got all of my functions listed here. I'm hiding the original functions, but notice I've labeled every single function. Instead of y equals, y equals, y equals, I've labeled them as f of x, g of x, h of x, k of x, and m of x. Now what I can do is, when I graph this, notice that it actually graphs the velocity function because I've just said for it to sketch the derivative. It even graphs the velocity function within the same domain as your function above, which is awesome in my opinion. So if I go and just click all of these, so you'll notice what I now have, the bottom line is my velocity graph. So then what I would have to eventually do is I'd be talking about my design in terms of safety. So we'd be thinking about this maximum velocity point. We'd think about the minimum velocity point. You could talk about other things involving speed. So remember, speed is just the magnitude of velocity, so without any direction. So basically, like, what we can tell from this graph here, like I can see that up until the 10-second point, the velocity is going downward, or it's a negative velocity. Then I start to move upward, which kind of makes sense because at this turning point here, now my BMX or my bike is starting to go upward. It reaches a point where it hits its maximum velocity, and then it's actually slowing down here. So this is the velocity graph. I can then repeat this same process to come up with my acceleration graph. So now what I've went and done is I've went and found the second derivative, which represents the acceleration over time. So this is my acceleration graph. So like I stated before, but I'm just going to state this again because it is important. Although Desmos can easily do this for us, which is good, you still are expected to derive all of your functions. You're meant to find the derivative of them, and you're supposed to verify algebraically, like, what is this maximum acceleration? What is this minimum acceleration? And what does it mean? So I just thought this was a pretty handy skill on Desmos that you can use in your PSMT. As in my next video, I'm gonna talk about how your design on grid paper doesn't have to match up exactly perfect with your design on Desmos. Remember, your design on grid paper is literally just a draft of what your final design is going to be. So the grid paper design and the Desmos design, they don't have to overlap perfectly. It would be good if they're close, but we're not expecting you to make every function exactly the same as what your design is on grid paper, which has been hand drawn. It's never going to be exact. Anyway, thanks for watching, guys. See you in the next video.